9.3 Queuing Algorithms. When network congestion occurs, the QoS queuing algorithm determines which packets are sent first and how bandwidth is shared. Number one, a FIFO, that's first in, first out. It's the simplest queuing method. First packet arrived, and then the first packet transmitted. All traffic is treated equally, no special priority for voice or video. During congestion, delay-sensitive traffic may suffer. And then we have the WFQ, that's the weighted fair queuing. It automatically separates traffic into flows. It gives preferential treatments to low-volume interactive traffic. High-volume flows fairly share the remaining bandwidth. It helps prevent a large flow, such as FTP, from dominating the link. The third one is the CBWFQ, which stands for the class-based weighted fair queuing. An administrator creates traffic classes. Traffic can be classified by protocol, ACL, DSCP, interfaces, and etc. Each class can be assigned a guaranteed amount of bandwidth. This provides more control than WFQ. 9.3.2 Queuing Overview. The previous topic covered traffic characteristics. This topic will explain the queuing algorithms to implement QoS. The QoS policy implemented by the network administrator becomes active when congestion occurs on the link. Queuing is a congestion management tool that can buffer, prioritize, and, if required, reorder packets before being transmitted to the destination. A number of queuing algorithms are available. For the purpose of the course, we'll only focus on following. First in, first out, the FIFO. The weighted fair queuing, WFQ. Class-based weighted fair queuing, the CBWFQ. Low latency queuing, LLQ. First in, first out, the FIFO queuing. This is the simplest algorithm. FIFO has no concept of priority or classes of traffic, and therefore makes no decision about packet priority. There's only one queue, and all packets are treated equally. Packets are sent out and interfaced in the order in which they arrive, as shown in the figure. Although some traffic may be more important or time-sensitive based on the priority classification, notice that the traffic is sent out in the order is received. When FIFO is used, important or time-sensitive traffic can be dropped when there's congestion on the router or switch interface. When FIFO is used, important or time-sensitive traffic can be dropped when there's congestion on the router or switch interface. When no other queuing strategies are configured, all interfaces except serial interface at E1 and below will use FIFO by default. FIFO is the fastest method of queuing, is effective for large links that have little delay or minimum congestion. If your link has very little congestion, FIFO queuing may be the only queuing you need to use. 9.3.4 Weighted fair queuing. Weighted fair queuing, the WFQ, is an automated scheduling method that provides fair bandwidth allocation to all network traffic. WFQ does not allow classification options to be configured. WFQ applies priority or weights to identified traffic and classified it into conversation or flows, as shown in the figure. WFQ then determines how much bandwidth each flow is allowed relative to other flows. The flow-based algorithm used by WFQ simultaneously schedule interactive traffic to the front of a queue to reduce response time. It then fairly shares the remaining bandwidth among high bandwidth flows. WFQ allows you to give low-volume, interactive traffic such as telnet sessions and voice priority over high-volume traffic such as FTP sessions. When multiple file transfer flows are occurring simultaneously, the transfers are given comparable bandwidth. WFQ classifies traffic into different flows based on packet header addressing, including such as characteristics as source and destination IP addresses, MAC addresses, port numbers, protocol, and the type of service value, called the TOS. The TOS value in the IP header can be used to classify traffic. Low bandwidth traffic flows, which comprise a majority of traffic, receive preferential service, which allows the entire offered loads to be sent in a timely fashion. High volume traffic flows share the remaining capacity proportionally among themselves. There are some limitations to WFQ. It's not supported with tunneling and encryption because these features modify the packet content information required by WFQ for classification. Although WFQ automatically adapts to changing the network traffic conditions, it does not offer the degree of precise control over bandwidth allocation that CBWFQ offers. 9.3.5 Class-based weighted fair queuing. The class-based weighted fair queuing extends the standard WFQ functionality to provide support for user-defined traffic classes. With CBWFQ, you define traffic classes based on the match criteria, including protocols, ACLs, and input interfaces. Packets satisfying the match criteria for a class constitute the traffic for that class. A FIFO queuing is reserved for each class, and the traffic belonging to a class is directed to the queue for that class, as shown in the figure. When a class has been defined according to its match criteria, you can assign it characteristics. To categorize a class, you assign it bandwidth, weight, and the maximum packet limit. The bandwidth assigned to a class is guaranteed bandwidth, delivered to the class during congestion. To characterize a class, you also need to specify the queue limit for the class, which is the maximum number of packets allowed to accumulate in the queue for the class. Packets belonging to the class are subject to the bandwidth and the queue limits that characterize the class. After a queue has reached its configured queue limit, adding more packets to the class causes tail drop or packet drop to take effect, depending on how class policy is configured. A tail drop means a router simply discards any packets that arrive at the tail end of the queue that has completely used up its packet holding resources. This is the default queuing response to congestion. Tail drop treats all traffic equally and does not differentiate between classes or service. 9.3.6 Low latency queuing. The LLQ stands for the low latency queuing that allows delay-sensitive packets such as voice to be sent first, giving delay-sensitive packets preferential treatments over other traffic. Although it's possible to classify various types of real-time traffic to the strict priority queuing, Cisco recommends that only voice traffic be directed to the priority queue. Without LLQ, CBWFQ provides WF queue based on defined class with no strict priority queue available for real-time traffic. The wait for a packet belonging to a specific class is derived from the bandwidth you assign to the class when you configure it. Therefore, the bandwidth assigned to the packet of a class determines the order in which packets are sent. All packets are served fairly based on the weight. No class of packets may be granted strict priority. This scheme poses problems for voice traffic that is largely tolerant of delay, especially variation in delay. For voice traffic, variations in delay introduce irregularities of transmission manifesting as jitter in the heard conversation.